Hello everyone, my name is Phil. I'm an engineer on the multi-cluster gateway controller project. I'm going to take you through a demo displaying the new interaction that we've made between the multi-cluster gateway controller and OCM, that's the Open Cluster Management System. I'm going to first of all explain this diagram that we're looking at here that's showing the single cluster setup, and then take us through a brief process of moving the single cluster setup to a multi-cluster setup, which I'll come to a diagram of that later. But first of all, I'll just briefly go through what we're looking at here. So this is a diagram just explaining the initial setup of the demo that we're going to go through. And in this case, we're running in a single cluster. And what I mean when I say that is that in OCM, there's a concept of a hub cluster, which is like the control plane of an OCM setup. And there is a spoke cluster, which is a cluster controlled by the hub cluster. In this case, the hub cluster and the spoke cluster are both the same cluster. And that's made clear from this. Here, the cluster set is a CR in the hub cluster, which defines spoke clusters that hub cluster can use. And in this case, the cluster set is referring to the cluster that the hub is installed into. So it refers back to itself as a spoke. In the sample that we're about to go through, there is a cluster set up like this with the multi-cluster gateway controller already installed and a managed zone already created on that hub cluster by the managed multi-cluster gateway controller. And we'll see that in more detail once we get over to the CLI. Okay, so here we are in our CLI where we're going to go through things in a little more detail. We have two terminals open, just to clarify what's going on with them. This terminal is pointing at the hub and spoke cluster. When we go to a multi-cluster setup later in the demo, this CLI is pointing to the second cluster that will be added. So for now we can ignore that, but just so you know what that's there for in the future. So the first thing that I want to show is that we have the managed zone set up. So I'll just bring that up now. And we can see here that the managed zone is set up for pb.hcpapps.net, and it's also configured in Route 53 as well. So the next thing that we're going to do now is create a gateway. So that's created now. So now what I'm going to do is show that there is only that gateway created, or in other words, it hasn't been recreated as the spoke instance of this cluster yet. That's because the hub cluster, or I should say it's because the gateway hasn't been labeled for any spoke clusters yet. So even though the hub cluster and the spoke cluster are the same physical cluster, the gateway only exists in its hub form here. And once it's labeled to be placed onto a spoke cluster, which is the same cluster, that's when we'll see the spoke version of this same gateway show up. Okay, so we're ready for that gateway to be synced to the spoke cluster now. The way we do that is by labeling the gateway with a placement name, and the placement refers to a cluster set which has a set of clusters that placement can use to put workload resources onto. So I'm just going to quickly go through how the cluster set and placement are configured to have this cluster refer to itself as a spoke cluster. So first of all, we'll just have a quick look at the managed cluster set. So this managed cluster set, as we can see, is set to match any clusters that have a label of ingress cluster true. So then if we have a look, and we can see here also that one managed cluster is matched against that label selector. So now if we have a look at the managed cluster, in this managed cluster you can see that it has that label of ingress cluster true, which is how it's been attached to that cluster set. So then we'll just quickly look at the placement that is targeting that cluster set. And in here we can see that we've specified that the cluster set that this placement should use is the one above, and we can say that the number of clusters is 1. And here then we can see in the status that the number of selected clusters is 1. It has found the cluster. So now to place that gateway, just to quickly show that there is only one gateway, still there is only the hub form of this gateway. So now I'm going to label that hub form of the gateway like so. This is a OCM label with the placement name that we want it to use to make a decision about where to put this gateway. And now if we do look at all of the gateways on this cluster, then we can see that the hub form of this cluster still exists, but there is this new spoke form of the gateway which exists in the spoke. So now what we're going to do is look at the DNS records and see that none have been created yet, because nothing is using that gateway yet on the spoke cluster. And we can see that the TLS secret has been created for the endpoint in that gateway created on the spoke cluster. Okay, so now we have a gateway in the hub and a gateway in the spoke cluster, and we have the TLS set up for that cluster, for that gateway. So the next thing I want to do is create the actual workload on the spoke cluster. So just to briefly talk about what I'm creating here, we can see that there is a HTTP route using test.pb.hcpapps.net. That's really the most critical part of this, is that it's going to be using the gateway that has been created in the spoke cluster. So I'll create that now. So now we're going to take a look and see that a DNS record has been created. And in this DNS record, we can see that it's got a single target, a single endpoint, pointing back to the 172.32.200.0 is the IP address of the single cluster hub and spoke cluster. I'm just going to give that 2 seconds to propagate before I do a dig, so that we can ensure that there's actually something to be returned when I do the dig. I think that should be enough time now, so we're going to see, yes, that the IP address is returned from a dig, and also we'll be able to curl that endpoint and connect to the workload that is running in the spoke cluster, like that. Okay, so there we've seen how OCM can be leveraged to allow us to deploy workloads to a cluster that is acting as both the hub and the spoke, as is displayed in this diagram here. So now I'm going to briefly go through the multi-cluster setup, and this is how that looks, where we have the hub cluster running the OCM hub parts of the infrastructure, and this is the part that was originally on the left of the diagram. And then we have the spoke cluster. This is the part that was originally on the right hand side of the previous diagram. And now we are going to be adding in a second spoke cluster, which is effectively this box here, which is essentially a mirror of the original spoke cluster that is running inside of the hub. We're now adding this second spoke cluster as an external cluster to the hub cluster. We'll go through that in more detail in the CLI now. So in order to enable the second cluster that we have created as a cluster that can be targeted by the placement that we are using, we first of all need to add it to the cluster set that that placement is referring to. We do that by patching the cluster. So as we can see here, we're patching a different cluster with the same label of ingress cluster equals true. So we do that, and then we can quickly have a look at the managed cluster set. And in the status here, we can see that it has 2 clusters now, so it's picked that one up. So now what we need to do is edit the placement. So let's just quickly edit that. So now we're going to have a look. As I mentioned earlier, this second terminal here is pointing at that cluster that we have just labeled and added to the cluster set. Now we're going to look in that cluster to see if the gateway has been created here yet. And we can see that it has been created. So then we'll create the workload on this cluster. Again, we can see that the host name in that HTTP route is using the same as the one in the gateway that has just been created in this spoke cluster. Okay, so that has been created now, and if we have a look at the DNS record in the hub cluster, we can see that this now has two targets for that DNS record. We've got the 200.0, which is the hub cluster, and 201.0 is the dedicated spoke cluster. So I've gone ahead and opened up route 53 here for the host zone that I am using for this demo. And we can see that the two A records have been created with .200.0 and .201.0, both for the same host name. There is a small issue around weighting at the moment, which means that the 200.0 is preferred in weighting over the 201.0, but nevertheless they're functional valid DNS records that are created. So now what we're going to do is a quick dig and see that the record is coming back with the .200. That's likely to be the case more or less permanently with that weighting. However, we can also just quickly do a curl to see that the endpoint is functional. Okay, so just to review what we've gone through in this demo, we can see that the single cluster is perfectly capable of acting as both hub and spoke, allowing developers to use that to deploy workloads to and have it managed by the multi-cluster gateway controller in the hub side of that cluster. And then we can also see how there is a convenient path to move from a single cluster acting as both hub and spoke to extra spoke clusters being connected back to that same hub and being used for the same workloads across multiple clusters. I hope you found this demo useful and informative. If you have any questions, I'd obviously love to hear them. Please write a comment below if you have any thoughts or feedback. If you want to go through this demo yourself, there will be links to a walkthrough and the branch in our repo that all of this code was executed against. So you should be able to run all of this locally very conveniently. And if you have any problems, put a comment in the video and we'll get back to you and try and help you as quickly as we can. Thanks very much.